So before we get into rational equations, I want to deal with the idea of domain restrictions. And what a domain restriction is basically, you can read that as an x restriction. Okay, these are values of x that you're not allowed to have, because if you do have them, they cause major problems. Now, in the context of a rational equation, you're going to have domain restrictions that pop up for one particular reason. You're trying to divide by zero. Other types of equations, like radical equations, have other kinds of domain restrictions, like if you tried to square root a negative. But for now, in this rationals unit, all we're dealing with is the divide by zero. We don't want to do that. So if you take a look at this first equation that we have here, it's very simple. F equals x plus 5. Are we dividing by anything? There's no division happening. There's no x on the bottom of a fraction. And that means no domain restrictions. Okay, so for this one, we have no domain restrictions. And the way you write that in interval notation is this: negative infinity to infinity. What that symbol right there means is that negative infinity to infinity, that means all the numbers, all of them in real space. Okay, the lowest negative number to the highest positive number, they're all fine. You could have negative a billion for x, and your answer is just negative a billion plus 5. It's a number. This one, on the other hand, this is different. Look at that, factor of x minus 1. You might be thinking, well, those factors just cross out, right? This is the same thing. It's not quite the same thing. If x equals 2, sure, it's the same thing, because at x equals 2, you get 7 times 1 divided by 1, that's just 7, which is the same as 2 plus 5. But check out what happens at 0. Okay, I'm going to try x equals 0 now. F of 0 equals 5 times, no, I'm sorry, not 0. I meant 1. F of 1. Okay. At f of 1, you get 1 plus 5, that's 6, times 1 minus 1 is 0, divided by 1 minus 1 is 0. Okay, so what's 0 divided by 0? Try it on your calculator. It's a big error. Okay, we can't do that until we get to calculus. So we want to be careful and make sure that we don't end up producing a 0 on the bottom of this rational. In other words, whatever x minus 1 is, and it can be all sorts of things, it can't be 0, which means x can't be 1, which means your interval notation is this: negative infinity to 1, union 1 to infinity. What this union symbol means is, watch out, there's a domain restriction here. You have to hop over 1. You can go right up until 1, almost getting there, but not actually hit 1. So if I had a number line like this, okay, and this is negative infinity, and that's positive infinity, all of the numbers on this line are perfectly fine, except for the number at x equals 1. Okay, so you can get right up close to it. You could be 0.99999, and that would be fine. It's not infinity, but you can't actually be 1 itself. So that's what we mean with interval notation. It's just a different way of expressing this idea of domain restrictions. Okay, so let's get into a real example here. Remember, I don't want the denominator equal to 0. That's the thing we cannot have. So let's factor that denominator first, and then we'll know what we're dealing with. When I look at 2x squared plus 5x minus 25, I pull the middle term, 5, down here, and I multiply the first and the last terms together. Okay, so that gives me negative 50. And then I want two numbers that multiply to negative 50, but they add up to 5. So that's going to be positive 10 and negative 5, right? Add them up, you get 5, multiply them, you get negative 50. So here's our factored form. X plus 10, and don't forget, you have to divide by 2, since that was the initial coefficient. And then over here, we get x minus 5, divided by 2. Okay, and that simplifies to x plus 5, and 5 over 2 does not simplify, so we have to take that 2 and move it in front of the x. This is your factored form. So here's the rewritten equation in factored form. You still have that x minus 1 on top. That hasn't changed. And then on the bottom, you have x plus 5 and 2x minus 5. So here's my question. Where is the denominator 0? Well, you have two possible conditions. Right here, x plus 5 can't be 0. Because if it is, then you have a 0 times a number, your whole denominator becomes 0. That means x cannot be negative 5. Okay, that's one domain restriction. And we have another domain restriction. Okay, right here. 2x minus 5 cannot be 0, which means x cannot be 5 halves. That's your second domain restriction. Okay, so let's write that in interval notation. And I'm just going to go down here because I have more space. The interval notation for this idea of domain restrictions is negative infinity. And what's your most negative domain restriction? It's negative 5. So that's where we have to stop. And then we hop over that restriction with the union symbol and pick up on the other side of negative 5. And we go all the way until 5 halves. Hop over that domain restriction, and then you're off to infinity.